Hello and welcome to Learn Yourself. Today we are going to learn about language of chemistry. This chapter is under ICSE Standard 8 syllabus. Let us start our chapter with symbol and valency. Symbol means what all elements we do have in our modern periodic table. There are certain sign and symbols for those elements, and they are also called abbreviated name of the element. For example, hydrogen. So for hydrogen we are using H. For copper we are using Cu. Sometimes we are using first two alphabets of the elements spelling, and sometimes we are using the only one alphabet of that element spelling. For example, hydrogen, then H. But it is not the case with copper. That original name was cuprum, and from that we are writing Cu for the copper and Co for the cobalt. Also for plumber it is Pb, and same for all other elements. So it is very important for you when you are learning a chemistry that you should remember all the symbols of those specific elements. Then only it will be easy for you to remember their valency and going forward in next standard the reactions, because basically chemical reaction we are writing with the help of symbols. Then second, valency. What is the valency? Valency is the number of hydrogen atom. This is a different concept compared to chapter number 4. In chapter number 4, we have seen in terms of electron donation or electron acceptance. In this chapter, one other concept is also there for the term valency. So the number of hydrogen atoms which can combine with one atom of the element forming a compound. For example, if we are writing ammonia molecule, then NH3. So in this compound, if we are checking the valency of nitrogen, then how many hydrogen has been attached with nitrogen? 3. So nitrogen's valency is 3, and it is true. Now H2O molecule, H2O. If we are writing a valency of oxygen, then oxygen's valency is 2. Why? Because how many hydrogen has been attached to it? 2 hydrogen. So that's what they are saying, that the number of hydrogen atoms which can combine with any other atom will be a valency of that particular element. If 3 hydrogen atoms are combined, then valency of nitrogen is 3. If 2 hydrogen atoms are combined, then valency of oxygen is 2. And for example, H2 molecule. Then in H2 molecule, how many hydrogens are there? 2 hydrogen. With one H, another H is combined. So hydrogen's valency is 1, and so on. We also know that whatever element is donating an electron or accepting electrons, that also can be its valency. How? Sodium is donating 1 electron and its valency is, sodium's valency is 1 because it is donating 1 electron. Similarly, chlorine. Chlorine is accepting 1 electron and its valency is 1. So, valency we are defining from 2 different concepts. First concept is how many hydrogen atom is combining with any particular element. That will be the valency of the other element other than hydrogen. And the second concept, how many electrons they are donating or accepting. That will be the valency of that particular element. The concept of variable valency. Valency, we know that number of electrons donating or accepting by any element will be its valency. So sometimes what will happen, that one element will show more than one valency. So they are known as variable valency. If they are showing more than one valency. For example, copper. Copper's atomic number is 29. So its electronic configuration will be 2, 8, 18 and 1. Now here, this we know that this is a valence shell. But the second last shell we call as penultimate shell. Penultimate means the second last orbit. So if you will see here, in 18 and 1, it has only one electron. So sometimes what will happen to become stable? To make two electrons in the last shell, one electron will jump from the second last shell to the last shell. Okay. In the first electronic distribution, it will be 2, 8, 18, 1. This is known as penultimate shell. That is second last orbit. This is last orbit. It is known as valence shell. So the copper will become more stable if in the last shell there will be 2 electrons. So what will happen that there are 18 electrons. So one electron will jump from the penultimate shell to the last shell. So the 18 will become 17 and here one electron will become 2 electron. So this both the state we can see in copper. So when this electronic configuration copper will show, the valency of copper in that state will be 1 because it has one electron in its outermost shell. When the copper will show this electronic configuration, the valency of this copper will be 2 because it has 2 electrons in its outermost shell. One electron from the penultimate shell has been jumped to valence shell. So if copper will make a compound with chloride in this valency, then it will be CuCl. In this form our copper is copper 1 chloride because its valency is 1. But copper 2 also can make a compound with chlorine. So it will be CuCl2 and in this it is copper 2 chloride. We know that sometimes we are writing iron 2 oxide and sometimes we are writing iron 3 oxide. So iron also show, Fe also show variable valency. Sometimes it is Fe plus 2, sometimes it is Fe plus 3. The same reason will be behind the iron's variable valency. Here copper 1 chloride will form and here copper 2 chloride will form because copper will show variable valency. And what are the variable valency of copper? Cu plus 1 in this case and here Cu plus 2 in this case. How to write chemical formula or how to write molecular formula. To learn this, basic requirement is you should know the symbols of almost all the elements and the valencies of the elements. So then only we'll go to this step. So when we are writing a chemical formula, we should know the symbols and we should know the valency. So when we are writing a molecular formula of hydrogen chloride, so how we are writing? First, we know that the molecular formula is HCl, but how it has come? Then let us write first hydrogen and let us write chlorine. What is the valency of hydrogen? It is 1. What is the valency of chlorine? It is 1. So when this two we are writing like this, then we are following one method, it named crisscross method. So whatever valency is of chlorine will attached with hydrogen and whatever valency of hydrogen will attached with chlorine. There are two rules. First one, that you are crossing valencies. Second, if there are one valency, then we are not mentioning in formula. If it is 1, then we are not mentioning that 1. Then if same valencies are there, then also we are not mentioning. So there are particularly 3 rules to follow crisscross method. See here. So we are crossing the valencies, but if it is 1, then we are not mentioning. So when we are writing hydrogen chloride, it is H1 because the one valency of chlorine, and C1 because one valency of chlorine. But in the molecular formula, we are not mentioning 1. So the molecular formula will be HCl. When you are writing H, it obviously that one hydrogen is present. So there is no need to mention 1 in that. So this is our molecular formula, HCl. Let us take another example. Zinc chloride. Let us write first zinc, and here we are writing chloride. What is zinc valency? It is 2. And what is chlorine valency? It is 1. So let us cross their valency. So when we are writing zinc, we are attaching chlorine's valency, and it is 1. So we are not mentioning the 1. And when we are writing Cl, 2 is zinc's valency, so we are mentioning here 2. So this is our compound zinc chloride. So this is the way we are writing a molecular formula for each and every compound. Let us take 2 more examples. First is zinc sulfide. So whenever in the exam you are getting write a molecular formula, the examiner will ask a name like this, and you have to write their symbols and their valency by your own. So please remember all the symbols and valencies. So here zinc sulfide. So what is zinc? It is Zn. And what is sulfide? S. In sulfur there are 2-3 different ions. Sulfide, sulfate, sulfite. They all are different. So you should remember those. So this is zinc and this is sulfide. Sulfide means S. So zinc's valency is 2 and sulfide valency is also 2. So we are crisscrossing these valencies. But as per our third rule, if both are having the same valency, then we are not mentioning it. So our compound will be ZnS and not Zn2S2. It will be ZnS. Then second, iron 3 sulfate. We know that iron shows variable valency. In this they have mentioned iron 3. That means Fe plus 3 we required in this. So iron is our Fe. And the valency what they have suggested us is 3. Now sulfate. So it is SO4. SO4 is minus 2. So it is going to be 2. Now if you will see both the valencies are different. So we have to mention both of them. So the molecular formula is going to be Fe2 and SO4 thrice. Here SO4 is one complete ion. It is anion. So when we are writing SO4, we are making this bracket and we are writing this 3. So this means 2 Fe ions are combining with 3 different SO4 negative ions. Let us practice some more molecular formulas. Here I have mentioned all the positive ions and here I have mentioned all the negative ions. Please pause the video here, write their respective valencies and try to write their molecular formulas. And if you have any doubt, please check out for my explanations. Now let us understand how this molecular formula will work. First is Mg, we have to combine with OH. So Mg's valency is 2 and OH valency is 1. So when we are writing Mg and we are writing OH, it is going to be 2 and 1. So by a crisscross method, it is going to be Mg1. So we are not mentioning, and OH, the complete OH is having 2. So we are going to write OH in a bracket and then we are writing 2. So it is MgOH twice. It is magnesium hydroxide. Let us go for the second one. It is zinc. Zincs and NO3. So zinc valency is 2 and NO3's valency is 1. So when we are crossing them, it is going to be zinc 1. We are not mentioning 1. And NO3, since there are polyatomic ions, so we are making it in the bracket and we are writing here 2. So it is zinc nitrate. Zinc NO3 twice. ZnNO3 twice. Let us check for copper and sulfide. Copper and sulfide. S is sulfide. Here it is 2. Here it is also 2. We are crossing them. But when both are having the same valency, we are not mentioning. So the compound will be CuS. Copper sulfide. Fe3, wherever it will be a copper or iron, please see if they have mentioned any variable valency or not. If not, then you are free to use one of them. So here it has been mentioned that Fe3. So we are going to write here Fe3 and oxygen, we know that its valency is 2. So when we are crossing them, it is going to be Fe2O3. Iron 2, iron 3 oxide. Now the same one with the Fe's valency is 2. So here we are going to mention Fe2, oxygen is also 2. So when we are crossing them, it is going to be FeO. So it is iron oxide. So this is the way we are writing molecular formula. Again, it is very important to remember all the symbols and their valencies. What is chemical equation? When two or more compounds are reacting with each other, they are giving certain product. And this we are mentioning in the form of molecular equation or word equation, that is known as chemical equation. Let us see the two form of chemical equation. This is molecular equation. Since we are writing all the symbols and molecular formula of that particular compound, zinc plus hydrochloric acid will gives us zinc chloride plus hydrogen. So this is a molecular equation. The second one is known as word equation. Since we have written all the compounds in the word form, zinc plus hydrochloric acid will gives us zinc chloride plus hydrogen. So this is molecular equation, this is word equation. Word equation we are writing in words, molecular equation we are writing with symbols and molecular formula. Now let us understand, when we are writing a chemical equation, what all things we are mentioning in it and what all information we are getting from the particular chemical equation. So this is our molecular equation. In this I have mentioned this S, D, I, L and G. Whenever we are writing this type of symbol in subscript, it shows the state of that particular compound or element. For example, S here. So it says that what we are taking is zinc is in solid form. That means zinc granules we are taking. DIL suggested that this is diluted hydrochloric acid. That means it is not concentrated. If it is concentrated, then it would have been mentioned as conc, but it is not there. ZnCl2 will be in the solution, and this is G. G means gas. So when these two are reacting, we will get zinc chloride, and hydrogen we are getting in the form of gas. So this will make us understand that in which form we are taking all the ingredients and we are getting in products in which form. When we are writing a chemical equation, there are two parts. These all are we called reactants. Reactants means what we are taking for our equation to happen, what we are taking to happen that reaction. They are known as reactant, and they are at the left hand side of the chemical reaction. This arrow shows us the direction of the equation. This arrow will suggest us that this reaction will follow from left hand side to right hand side. This, what all are there after the arrow, they are known as products, and we are writing at the right hand side. That means when reaction will complete, you will get these two products. So these are reactants, these are products. Arrow suggests us the direction of a reaction. Sometimes you will get to see this kind of arrow. This suggests that this is a reversible reaction. From left to right also it is possible, and after some time from right to left also it can be possible. So this shows a reversible reaction. This is a normal reaction where it proceeds from left to right. All this information we are getting from a chemical equation when we are writing in a molecular form. But certain things we do not know. We cannot know from the chemical equation. What are they? Let us discuss it. There are certain things which we do not know from a molecular equation. So they are termed as a limitation of chemical equation. When we are seeing that chemical equation on paper in writing, we do not know or we do not make out certain things. So they are termed as limitation. Let us see what are they. Physical states. If we have mentioned that this is a gas, this is solid, this is liquid. If not, then we will not make out that what will be the physical state of that particular product or that reactant. Second, temperature and pressure. How much temperature we should keep, or how much pressure or temperature will be generated when the product will be generated. These things we will not get to know from the molecular equation. Concentration. How much concentration is required for our reaction? We do not know from the molecular equation. Sometimes if concentration required and we are not giving that much concentration, that reaction will not happen. So the concentration is very important thing, and that we do not know from the molecular equation. Nature. Nature of the particular reaction, whether that nature is acidic or basic, or which kind of that reaction, whether it is exothermic, endothermic, we do not know. Then speed. Whether this reaction will happen in 5 minutes or at the moment or after 1 hour, we do not know the speed of the particular reaction. Heat. Whether heat will be generated at the end or not, that we do not know from the molecular equation. And completion. By seeing a molecular equation, we do not know that when the completion of reaction will happen, how much time it will take, and what are the observations for that particular reactions when it is completed. So though this specific things we do not know from a written molecular equation. So these are termed as limitation of chemical equations. Let us learn balancing of equation. This topic is very important because you are going to learn a next two segments in respectively standard 9 and standard 10 syllabus. So this is a basic of this topic. So balancing of chemical equation. What is the meaning of balancing of chemical equation? We do know that there are certain reactants and there are certain products in the chemical equation. When the reactants are equal to the product, for example, how many atoms I am keeping in, how many atoms I am putting into the chemical reaction, those many atoms only I am going to get at the end of the reaction. Nothing should be added, or there is no change in the number of atoms when any chemical reaction will happen. So nothing is going to miss or nothing is going to add apart from those total reactants, those atom of the reactants. So those things we have to balance. We have to check the number of atoms what are present in the reactant side, and we have to make it same with the products. So let us see. First example, here I have sodium oxide plus water will gives us sodium hydroxide. Let us first check this equation is balanced or not. How to check that? This is my reactant side and this is my product side. So how many atoms are there in total? Sodium is there, oxygen is there, then hydrogen is there. This oxygen I have already mentioned here. So let us first count how many number of atoms are there. How many sodium are present? 2. How many oxygen are present? So when you are counting oxygen, please see that in another molecule also oxygen is there. So this is one oxygen, this is second oxygen. So there are total 2 oxygen. Now hydrogen. How many hydrogens are there? 2 hydrogens are there. So there are 2 sodium, 2 oxygen and 2 hydrogen. Let us check from the product side. It is sodium, oxygen and hydrogen. Sodium is also 1, oxygen is also 1 and hydrogen is also 1. So if you will see, all are double in the amount compared to the product. So when you are balancing and chemical equation, you have to add certain number to the front of any reactant or product. You cannot add anything in the subscript. Always you have to write at the front, because when you are going to add, you are going to add a molecule. You cannot add any particular atom. So if you are writing here 2, 2, 2, then it is wrong. Like this you cannot balance any equation. Whenever you are balancing, you have to write any number over here, here and here. If you will see, all are 2 and all here are 1. You cannot make it less also. You cannot take out any molecule. So only thing you can do is you can add a molecule. So if I want to add, then if I'll add here a 2, then let us check now. After adding 2 here, what is a condition of my product here? So how many Na is there? When 2 is here, it is applicable to all the atoms over here. It is applicable to sodium, oxygen and hydrogen. So how many sodium are there? 2. How many oxygen are there? 2. How many hydrogens are there? 2. So if you will see, all are 2 here and all are 2 here. So now my equation is balanced. Earlier it was Na2O, H2O and NaOH. So I have added 2 here. And now my equation is balanced because all the number of atoms in the reactants are similar with all the number of atoms in the product. So this equation is balanced. Let us take another example. NO plus O2 will gives us NO2. So let us write all the atoms are present at the reactant side. It is nitrogen and oxygen. In both the molecules there are only 2 atoms, nitrogen and oxygen. So nitrogen is only 1 here. When we are counting oxygen, we are counting oxygen from both the molecules. So it is 2 plus 1. It is going to be 3. Now let us check at the product side. In product side, only 1 molecule is there. So in that, nitrogen and oxygen. Nitrogen is 1 and oxygen is 2. Now let us compare them. Nitrogen is 1, nitrogen is here also 1. So we don't need to balance nitrogen. Here oxygen is 3, here oxygen is 2. So we have to balance oxygen. So as we discussed earlier, we can add any molecule at both the sides and we cannot add any atom. So if we are going to add here 2, we cannot add anything here. We have to always add any number of molecule at the front. So let us check this. How many nitrogens are here now? Nitrogen is 2 and now our oxygen are 2 plus 2. It is 4. This is our new atoms. So now here it is 2 and it is 4. It has already doubled. So if I am going to write here 2. So now 2 and 4. So this equation is balanced. What I have done is I have added 2 NO at reactant side. So they both became double. This 2 and this 2 became 4. So here I have also added 2. So this 2 NO and altogether 4 oxygen.